Next question is about inclined plane. Now, whenever we are solving problem with inclined plane, in regular vectors, when we are finding components, we take the x component to be a cosine theta and y component as a sine theta. But when you are solving problems with inclined plane, we switch these values. For inclined plane, your x component will become a sine theta and y component will become a cosine theta. This is very important when we are splitting vectors or when we are finding components along an inclined plane. X component will be sine theta, y component will be cosine theta. Now let's look at what the question is asking and let's see how we can solve a question like this. In this question, you have a snowboarder who is with a mass of 72.9 kilogram and a height of 1.79 meter, glides down a slope with an angle of 22 degrees with respect to horizontal. If we can neglect friction, what is his acceleration? Now, step 1 in solving any such problem that involves forces, multiple forces acting on an object, is that you have to draw the free body diagram. Always first draw the free body diagram, then we can go to solving it. So in free body diagram, force due to gravity will always be acting vertically downward. Then is the normal force which is acting perpendicular to the surface. So if I were to draw it over here, this is my inclined plane, this is my object. Force due to gravity will act vertically downward. This is my FG. Normal will be perpendicular to the surface. Now for an inclined plane, x-axis is along the incline. So this is my x-axis. Y-axis is perpendicular to that surface, perpendicular to x. This is my y-axis. Normal will be along y-axis, perpendicular to the surface. And since we are neglecting friction, I will not have to draw friction here. Then after you draw these two forces, I have to split force due to gravity because Fg is neither on the x-axis nor on the y-axis. So we split Fg, one along the x-axis, which is Fg x, one along the y-axis, which is Fg y. So this is the first step for solving any question in chapter 4 that involves forces. First, draw the free body diagram. Second step is to identify the forces. What are the magnitude? What are the values of these forces? Fg is m into g. And since we divided Fg into two components, x component of Fg will be Fg sine theta. So that I will write as mg sine theta. Y component of Fg will be Fg cosine theta, which I will write as mg cosine theta. The third step, we write equation of forces. If they don't give you friction, if they ask you to neglect friction, we neglect the forces along y-axis and only consider forces along x-axis. So along x-axis, you have only Fgx. Now, if the sum of the forces, if the object is moving with constant velocity, we take the sum of the forces to be equal to 0. If it is moving with constant velocity or if the object is at rest, we take the sum of the forces to be equal to 0. But if the object is accelerating, we take the net force, the sum of all the forces along that axis to be equal to m into a if it is accelerating. So since the snowboarder is accelerating here because that's what they're asking us in the question, to find acceleration. Since the snowboarder is accelerating, I will write F net x equals m into a. Now, there is only one force acting along x-axis, which is Fgx. I will write Fgx equals m into a. Substitute for fgx, mg sine theta equals m into a. Cancel off m because it's the same for both on both sides. You get a equals g sine theta. Substitute the value of g, 9.81 sine 22, and you get your acceleration as 3.67 meter per second square. Question 4.48. Here you have a mass m1 with 20 kg on a frictionless ramp is attached to a light string. The light string passes over a frictionless pulley and is attached to a hanging mass m2. The ramp is at an angle of 30 degrees above the horizontal. m1 moves up the ramp at constant speed. Find the value of m2. If m1 is moving up the ramp at constant speed, that means acceleration is equal to 0. If m1 is moving up at constant speed, m2 has to go down with the same constant speed. Acceleration for both of them has to be equal to 0. Constant speed means net force 0, acceleration 0. So we start with step 1, where we have to draw the free body diagram. So let us start with m2. Identify forces acting on m2. The first force that always acts on every object is the force due to gravity, which is always pointing vertically downward. So I will write for m2 that to be equal to fg2. Second is tension in the string. Since m2 is hanging by a rope, there is a tension which is pointing towards the suspension point. Then we come to mass m1. Again we draw fg pointing vertically downward. F normal and tension. Fg I will split into component, one along x-axis, the other along y-axis. In step 2, we identify what are these forces. Fg we know is equal to m into g. So Fg1x will be m1g sine theta. Fgx along an incline is sine theta. Fgy along an incline is with cosine theta, so Fg cosine theta, m1g cosine theta. This is for mass 1, that is why we have taken m1. Step 3 is to write equation of forces. So first I'm going to write for block m2. We know since m2, it's moving with constant speed. Constant speed means acceleration is 0. And if acceleration is 0, the net force along this axis also has to be 0. So I write F net equals 0. Now what are the forces acting here? Net force means adding all the forces including their direction. So since T is pointing up, I will take it positive. Fg is pointing down, I will take it negative. So T minus Fg2 equals 0. Fg we know is m into g, so I write it as T minus m2g equals 0. Rearrange the term and write T equals m2g. I will write this as equation 2. Then we go to the mass 1. Mass 1 is along the incline. And on this incline there are two axes on which forces acting, y-axis and the x-axis. Since there is no friction, since we are asked to ignore friction, I will not consider the forces along the y-axis. I will only consider forces along the x-axis. Again, since m1 is moving at a constant speed, the net force acting on m1 has to be 0. So F net 1x, x because it is along x-axis, is equal to 0. So here there are two forces acting. One is tension on the string. The other one is Fgx. So I write T minus Fgx equals 0 because Fgx is along negative x-axis, T is along positive x-axis, so T minus Fgx equals 0. Fgx is m1g cosine theta, and I rearrange the term again to write T equals m1g sine theta. Now both of these equations, equation 2 and 3, is T equals something, T equals something. Both of these are equal to T. So I'm going to equate equation 2 and 3. They are both equal because both of them are equal to T. So we write from equation 2, m2g equals, then equation 3, m1g sine theta. Cancel off the common term which is g. m2 equals m1 sine theta. I want to find m1, I want to find m2. So substitute for m1. m1 is 20 sine 30, and you will get m2 as 10 kilogram. So if an object is at rest or moving with constant speed, you will take their F net to be equal to 0. We only take F net equals m into a when the object is accelerating. Question 4.81. Here you have a block of mass 5 kilogram that is sliding at a constant velocity down an inclined plane that makes an angle of 37 degrees with respect to horizontal. What is the friction force? What is the coefficient of kinetic friction? Here in this question, again we begin with the steps that we follow. First we draw the free body diagram. So a block is sliding down an incline with constant velocity. Constant velocity again means my acceleration has to be 0. So the first force that will act on the block is force due to gravity acting down, and the normal force and the force of friction opposite to the motion. Then we split gravity into x component and y component. After we do that, we write down what individual forces are equal to. Fg is m into g. Fgx will be Fg sine theta, so mg sine theta. Fgy will be Fg cosine theta, so mg cosine theta. Since we are including force of friction here, force of friction is equal to coefficient of kinetic friction times the normal force. So we need to write down all of these forces so that when we are solving the equation, it's easier to substitute them. Now let's go to the next step. Since we have friction in this question, we have to consider the forces on the y-axis. We have to take them into account. So I will start with all the forces which are acting on the y-axis. Since the block is not moving along y-axis, acceleration along y-axis is 0. And if acceleration is 0, the net sum of all forces along y-axis also has to be 0. So F net y is 0. Now see which forces are on y-axis. You have the normal force pointing up, so F normal, force due to gravity coming down, so minus Fgy equals 0. Fgy is mg sine cosine theta, so I write Fn minus mg cosine theta equals 0. Rearrange them to get the value of Fn. After that we go to the x-axis. Again in x-axis we are moving with constant velocity. And if you are moving with constant velocity, we write F net x equals 0. Constant velocity means acceleration is 0. And if acceleration is 0, the net force will also be 0. The two forces along x-axis are the force of friction and Fgx. So F force of friction minus Fgx equals 0. Force of friction you write as mu k Fn. Fgx we will write as mg sine theta. So mu k Fn equals mg sine theta, or mu k equals mg sine theta over Fn. Fn is the normal force which we found here already. I will write here as mg cosine theta. Cancel out the common term. You get mu k as sine theta over cosine theta. Substitute the value of theta to get mu k as this, 0.75. Since mu k is a ratio of two forces, it doesn't have a unit. Then you have to calculate the force of friction. Force of friction is coefficient of kinetic friction times the normal force. So mu k mg sine cosine theta. I have the value of mu k, 0.75, m is 5, g is 9.81 into cosine 37. Substitute this value and you get the force as 29.4. We consider y components whenever we have friction. If we didn't have friction, we always start with the x component of forces. Now, same equation of the same problem of the snowboarder, but this time we have to consider friction. So in this question, you have to reconsider the snowboarding situation from solve problem 4.1, but now include friction. You have a snowboarder moves down a slope with theta 22 degree. Suppose coefficient of kinetic friction is 0.21 and its velocity along the direction of slope is 8.3. You need to find, assuming a constant slope, what will be the speed of the snowboarder along the direction of the slope 100 meter further down the slope. So you want to find its speed 100 meter further down the slope. If I want to find speed, I first need to know what is the acceleration of the snowboarder. Once I know the acceleration, then I can use any one of the equations of motion to find the speed. So let's start with step 1. In step 1, we draw the free body diagram. Then in step 2, we specify all the forces that we are using. I have Fg equal mg, Fgx mg sine theta, Fgy mg cosine theta. Force of friction is mu k Fn. And since we are considering friction, in step 3, we will write the equation of force along y-axis. Whenever you have friction, first start with the y-axis, because when we go to the x-axis, we need the normal force. And the normal force you will get by considering equations of forces along y-axis. So since the object is not moving along y-axis, net force along y will be 0. Acceleration along y is 0, so net force will also be 0. Along y-axis, you have the normal force and y component of Fg. So Fn minus Fgy equals 0. Fn will be equal to Fgy, and when you substitute for Fgy, mg cosine theta, that's the value of Fn. This we always need to substitute for the force of friction, because friction is mu k Fn. After we get this, we go along x-axis. My object is accelerating along x-axis, so I will write my F net equals m into a. Whenever you have acceleration, you write it as m into a. Along x-axis, I have Fgx and the force of friction. So Fgx minus force of friction equals m into a. Fgx is mg sine theta. Force of friction is mu k F into n. F into n is mg cosine theta. So in the next part, I have written mg sine theta minus mu k. In place of Fn, I have written mg cosine theta from here. A is common. M is common for all, so I will cancel m. You can only cancel m if it's on each term on both sides. So I'm left with g sine theta minus mu k g cosine theta equals a. Substitute the value, that will give you a as 1.76 meter per second squared. Once I get a, now I can solve to find my speed. Question has already given me the initial speed. I have the acceleration. I have the displacement, 100 meter. So I will use the last equation of motion to find my final speed. V final equals V initial plus 2a delta x. I will take square root of this term to find my final speed, because this is Vx squared. So Vx is square root Vx squared plus 2a x final minus x initial. Substitute the values and you get your V as 20.5 meter per second. So steps are quite simple it's quite simple to solve if you go step by step. Step 1 will always be to draw a free body diagram, specify the force, write down equation along y-axis if you have friction, If you don't have friction, just start with equation along x-axis, solve, and to get whatever the question is asking you.